thing slowly. All right, guys. No, I'm going to show you because I don't know if everybody understood Charles's thing or heard it, and I was not able to figure out how to do what Olivia asked of like embed the link so that you can skip ahead. So, how do you watch a video? Let's say you pull up the video in the folder on Schoology. So I'll go to yesterday's folder on Schoology. You click open the video. Yesterday was Shell's Day 1. You click on that, and you can see, oh, cool, I can watch the video.
We have pictures,
but you can't scroll through it. So what you do is you, what? Thank you. I'm not going to be able to see this, actually. Nah, it's fine. Yeah, screen share. Good idea. So, share the screen. A tab. Well, that's not going to do it for the video, because in the video I'm recording what's on this screen. Oh well, they'll just have to listen. So anyway, how do you watch this so that you're not having to like watch the entire thing and you can't skip over me when I like just go off topic? What you do is you double click or right click here, and then you'll get these options. You select copy the video URL. You open up a new tab or a new window. You paste that thing that you just copied, and now, ta-da, you have control. And you can watch this thing.
We have pictures,
and you can jump ahead.
So then we run
you can increase the speed and make yourself really fast.
And now we're going to do things in terms of X. That's going to be a lot easier.
Or really slow.
For this reason.
And so on. So that's how you do that. Yes, Michaela. So if you right-click on here, then you can copy the link from there, and then new tab and paste. Yep. Any other questions? Yeah. Diane. Are they about the homework? Okay. Fair question. So let's come back over to here and talk about 18 first. So for 18, can you turn the light back on, please? All right. This can disappear, and then that can. All right, 18, we've got x plus y squared equals 16, and that is a leftward facing parabola. Here's 16 out here. And I think this is 4 and -4. And then we're going to cut this off so it doesn't continue on past the x-axis. And we rotate this thing about the x-axis. So what, and then they tell us use shells. So we're taking this here, parallel to our axis of rotation because we're going to do shells. Let's first talk about R and H. So the radius is the distance from a given shell back to the axis of rotation. And because we're above the axis of rotation, this distance is y minus 0. So I'm going to label this in here R. And then R is, this is at a location y along the x-axis. And then you subtract the axis of rotation, which is 0, so R equals y. Any questions with R? For the height, that's the length of the shell, and the length of the shell is from the curve back to this edge. Because we're perpendicular to the y-axis, we've got to do stuff in terms of y. So we come up here and isolate x to have the equation in terms of y, 16 minus y squared. And so the height is the curve, 16 minus y squared, minus 0, because this is going from the curve to the y-axis, x equals 0. So 16 minus y squared minus 0, there's your height. And no matter where you locate this shell, the height is always going to be the curve, 16 minus y squared, minus the y-axis, x equals 0. Does that answer questions about where we're getting r and h?
And we can do it again for 16, right?
Yeah.
We'll get it, but like I had seen another problem.
Yeah, I think 16 is a little tougher for these things than 18. The difficulty with 18 now comes with setting up your integral, I think. So when you go to integrate this, you got to keep in mind we're rotating about the x-axis, not the y-axis. And so we're doing everything in terms of the y. You might think, oh, we should do 2 pi because shells, and then negative 4 to 4 of your r, that's y, times your height, 16 minus y squared dy. That would be a reasonable thing to write down because you have this whole area from negative 4 up to positive 4. But in reality, we don't want to go all the way down to negative 4. We only want to go down to 0. And the reason for that is because we're rotating about the x-axis. So as we rotate this thing, the top half of this parabola is going to swing through the same exact region as the bottom half is. So the top half is going to swing into the page, around and behind, and then back up out of the page towards you and back to the top. And this bottom half is going to do exactly the same stuff. It's going to swing out of the page at you, come up and around, into the page behind, and these things are going to just duplicate. Each one is going to do exactly the same space as the other. So there's no need to count it twice, because you're not like doing extra volume by having this thing here. If we took this away and made just this the region, the volume that's getting passed through is going to be exactly the same volume. It's going to be all the same space. This extra wing down here just kind of is having 2 fan blades going through the same space instead of only 1 fan blade. So you can imagine, like, if I put my hand here and this is spinning around like a fan blade, and the fan blade goes bloop, 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 bloop against my hand, this fan blade here is going to hit my hand. And if I had the other thing here, that would also hit my hand. It doesn't mean I have 2 hands here. I've only got the 1 hand. So I don't count the hand twice just because it's getting hit twice by the fan blade. So that's why we only go from 0 to 4. We don't want to double count volume that's only the single volume that's happening. I don't know if I articulated that very well. Does that make sense?
No, I don't.
Okay. So that's
So
why that's the integral, not from negative 4 to 4, and not negative 4 to 4 turns to this and double. Diane?
So is it because of the shape, so only for parabolas, or?
Well, anytime you have like a region where the way you're rotating indicates that you're going to be double counting the volume, the same space. Like if we rotated this around the x-axis, then we would be doing disks. And if we rotate around the I said the x-axis.
Yeah.
If you rotate around the y-axis, first of all, we'd be doing disks instead of shells. And secondly, is the top half of the parabola going to be swinging through the same space as the bottom half of the parabola now? No, because this is always above the x-axis and this is always below the x-axis. So now the 2 halves of the parabola would be swinging through distinct spaces that are different. But if we're rotating about the x-axis, the space that this top half rotates through is exactly the same as the space that the bottom half rotates through. So you got to pay attention to what are we rotating about as to whether or not the whole region matters or not. So you're having to think in 3 dimensions inside your head, which is hard, especially if you got introduced to screens at a young age and didn't play with like blocks and things, or stick your hands inside of fan blades as they were spinning. I don't encourage you to go home and like stick the hand inside the fan blade. I remember doing that when I was like 3. It hurts.
It makes fun noise.
Mm-hmm.
It does.
And if you just stand there and like and then like Caleb and Luke love doing that. Anyway, 16. Oh yeah, I was gonna get you guys pictures of my kids to like enjoy how cute they are.
You need to bring your
I forgot to do that.
When you get started.
Yeah, that's not great for like 3-year-olds. He's a very, very high energy person.
Yeah.
I feel like the building would just
Colbert will take care of it. I don't think Colbert will take. Well, he doesn't know any of the other things. Liberty.
It's the teacher's fault, not the kid. So here, are we rotating about which axis again? It's got to be the x-axis because this is parallel to the x-axis we're doing shells. So in this one, your radius is this time below, like the location of the shell is below the x-axis. So when you figure out your radius, r, remember with everything, radius, height, area, it's always big minus little, top minus bottom, right minus left. So for us, top minus bottom for the radius, the top is the axis of rotation at 0, and then the bottom is your location along the y-axis. And you subtract them. So like before, when we were above the x-axis, the location along the y-axis came first, and then you subtracted 0. But now, the axis of rotation is on top, so that goes first, and then you subtract your location along the y-axis, and that's how we get r to be negative y. So does that make sense for r? Then height is this distance here across the rectangle. Again, big minus little, in this case, is right minus left. So what's the right edge of this region? 3. And the left edge is the line. And because we're, I guess we're rotating about the x-axis, and so we have to be doing things in terms of y. A little confusing. Yeah, you look at this. So hey, r is y, so we got to be doing stuff in terms of y. So we got to rewrite this thing, isolate the y, so add the x, subtract the y, 1 minus y. And so we have 3 minus the line, which is 3 minus 1 minus y. And so that's why our height ends up being 2 plus y. Once you've got your radius and your height, putting them together in the volume is not bad. 2 pi r times h is negative y times 2 plus y dy. And then you got to get your bounds of integration. We're doing stuff in terms of y, and that takes us from negative 2 up to 0. So negative 2 up to 0. And then from here, you'd be on your way. You'd be fine. This is getting to this point and fighting through your radius and your height. Michaela. For shells. For discs and washes, the opposite is true. Yeah. So that's what can make things confusing is what method you use kind of dictates what variable you're going to be working in. So when you would be working in terms of y with shells, you'd be working in terms of x with discs. No? That's the thing that you need to oh, can we say, let's go from 0 to negative 2. Remember, not now. You can switch the order, but you can't change it. What do you do? To switch the order, you're right. You just drop the negative, make it all opposite. So if you wanted to go from 0 to -2, which is reasonable, because then you get to plug in -2 and subtract it to get to 0. So if we want to change this so that our bounds are reversed, start at 0 and then go up to -2, then the result is the opposite, because you could just pull this negative out and then drop it. You have that. I probably wouldn't bother doing that. I'd probably just shoot the negative y and go, but that's legit. Sam?
Can you explain how you
This 3?
the 3 not 0?
So for the height, that's the distance across this region horizontally, because our rectangle is oriented horizontally. We want to be parallel to the axis of rotation for shells. For the height, we're basically doing right minus left. The right edge is a 3, because they told you, hey, look at the picture, right edge is a 3. So right minus left gives us 3 minus the line. So this 3 is always the right edge, and then the line is always the left edge.
Why doesn't that matter for up and down?
Because most of the time so far, looking at what I assigned, I think pretty much the rest of the time you had one of the edges being an axis. So that's a default 0. So you're subtracting 0 from stuff. For 11, we were rotating around the y-axis. So for 11, we have y equals absolute value of x minus 2. So that, and then we're going out until x equals 4. So that's the graph of x minus 2. It intersects the x-axis at the 2, and then it goes to 4, and then we have y equals 0 here. So this is our region, and then we're revolving it about the y-axis.
What if you revolve it around the x? Then would you have to do more plus or like?
So if we revolve this around the x-axis instead, the what-if game gets us in trouble sometimes. So if we were going to revolve this around the x-axis, first of all, I would probably do discs. Because then this is r, and r is just then the curve minus 0. Why didn't we do discs for 16? Because they want you to practice shells. But yes, 16 would have been pretty easy with discs. So 16 is one of those situations that can go either way, and it's not really easier or harder one way or the other. 11 is definitely easier with discs if you rotate about the y-axis, or the x-axis. And it's definitely easier with shells if you rotate about the y-axis like it says in the book. So if we were to try to force this to be shells while rotating around the x-axis. All right. So in this case, r would be y, and h would be 4 minus the curve, 4 minus curve, but then you'd have to write the curve in terms of y, and that would be y squared plus 2, or x equals y squared plus 2. So we'd have 4 minus y squared plus 2 for your height. So that wouldn't be bad. It would just be a little annoying to have to rewrite the equation. Because you had a question about something. So it's not. So it wasn't in the homework. So she's taking, let's try number 11. Think about number 11. But in the book, number 11 said rotate around the y-axis. And she's saying, well, what if we rotate around the x-axis? That's the same question Michaela had like a week ago with another homework. What if we don't? Well, then we don't have a question. Is that, Michaela? Okay. That's a Wednesday. We have lots of time on Wednesday, so we can answer some questions. Any other questions with the homework? No. Okay, what was the thing you asked earlier?
But it was like, what if it was like y plus 2 or like, remember?
Oh, like when do we have to worry about like subtracting a not zero?
Yeah.
When the
So if the shape is
like for the radius, that would be if we're rotating about not the axis. So
what about the height of it? Yeah. So what about the height?
yeah, so I'm gonna try to make something up and see how this goes. So yeah, we'll see how. I'm not saying this is gonna go well.
Why don't you just use one of
About
those?
y equals root x and rotate. And let's give this bound. So how about x equals 0 and x equals 4 and y equals 0 and rotate about, well, let's say x equals 1 actually. Rotate about line,
I think the life would be much easier.
no, I've already committed. X equals -2. Because I said -2. All right. So 1 comma 1, 2, 3, 4 comma 2. You got your curve. Fair? X equals 1, x equals 4, y equals 0. Then we're going to rotate this about the line x equals -2. Because I decided we're going to rotate about y equals this vertical line. So that we get Noel's question in action.
Does it matter?
So we want,
We want the dot to be away.
and we're doing shells. Why do we want to do shells? Actually, this is a good example to do shells. If we were going to do discs and washers, then we would have to write things perpendicular to the axis of rotation. And let's see what happens when we do that. That's bad because while the outside edge is always 4, and that's not terrible, the inside edge is 1 until you get up here, and then the inside edge is the curve. So we would have to have two integrals, one from 0 to 1, and then a second integral from 1 to 2, where little r changes from being 1 to being the curve in terms of y. So x equals y squared. So this is a situation where you could do washers, but you could do washers, but shells is going to be less painful. So let's do shells. So our rectangle is parallel to the axis of rotation. And then in this case, radius is the distance from the axis of rotation all the way out to imaginary rectangle. This rectangle is located at a location x, somewhere along the x-axis. And then right minus left is going to be x minus the axis of rotation. And that gives us x plus 2. Now, for the height, sorry, the height is still just the curve. So height is root x. If I made this region y equals 1, then it would be root x minus 1. Because now height is just from here down to here, and we're not doing this stuff. The shape is floating. So it's a if it's a floating shape that's not on an axis, then your height is going to be kind of restricted in that way. That's a good rule of thumb. Kayla?
It
Okay, so you want this to be x plus 3? But the distance r is, like, x is just where you are on the x-axis. So x is x. And then the distance from there back to here, like if you start at 1, then 1 plus 2 gives you the 3. So that concern is built into the x. And then you can kind of finish taking care of it by saying your integral is going to go from 1 to 4. And then we have r times h. Like so. Cool. I'm pretty pleased with how that turned out, with just making it up on the fly. Yay, go me. I could do this as a YouTuber. No. Michaela.
So, but then we have to add that rectangle.
Well, I changed the problem, so let's not. But even if we were doing shells, like if we were doing shells and this extended all the way to the bottom, then that just changes the height,
So what is it without?
and we're set.
So what was it?
-1 because the region stopped here. If we go back to the way it was originally, and the height is all the way down to the x-axis, then the height is just the height of the curve, and that's root x. What do you mean?
You said
No, this is shells.
Yeah.
no, but if you got rid of it, so if you went back to 1, would that also be shells?
Yeah, we'd still be doing shells. The other way, you could do disks more easily, but it would still require rewriting this in terms of y, which isn't really any easier than this is. Actually, it probably would be a little bit easier, because then you wouldn't have to worry about distributing this whole mess out inside. Yeah. So there's all these things to consider. If you're ready to like set up two different integrals, what if I did the shells, what if I did this disk, and then compare which of these integrals looks like it's less painful to then do. But then you have to go all the way to that point with both of them, and that's already a fair amount of work. Dice. So we got 4, 4, 5, 6, 6. So I'm going to collect those 1, 2, 3. What?
Just try it, right? Tell me if it tastes like eggs. Eggs? Yeah. So it goes.
It might just be my pet. I don't know.
You should take a look at the pack.
I've brought the grapes in the past, and a significant number of them are
What do you want?
bushy. So, I didn't mind it, but that was pretty good.
Oh my god, can I write my name? Like,
Yes, please. Use the right name.
well, he's actually like, it's like illegal.
Well, I mean, it's his arm. If he wants to get his own card, it's fine. While Noel's arm gets tired and falls off, you guys asked for extra work,
Yes,
so
because I don't want to fail the test.
I'm gonna make sure you won't run out.
Here's how I'm confident because we're gonna test and then record it close the video on Friday.
Can you
That is
put
so
the test in for next
You
week?
can curve the test.
Please.
I think you should pre-curve the test before we
Can you put
because
the
that's
test
what you
in
still out of
for
pocket.
the next month?
So here is a worksheet on just practice with cross sections.
What? You make it
It's gonna be so out of
I mean,
pocket.
we'll
We're
take
gonna
the
test
test,
right
but
off
it's like
the
a grading.
presentation.
Because then we'll have 2 tests for one period. For
You'll have to make them yourself. I will consider it. That's fine. Did you get one? Oh, Noel hasn't passed them back yet. All right.
Oh,
So-
well, I don't have to draw my problem.
That was cross sections worksheet. Next, here's a worksheet on just washers versus shelves.
Wait, are we doing worksheets or are we doing examples?
So what I'm handing out right now is just extra practice to help you prepare for the test. So what are we doing? I'm making sure, I will guarantee you will not run out.
So what are we doing in class?
That example 3.
Can you just give my extra answer? Like, our
They're all posted on Schoology. So
What is this? What are we solving for?
you're just setting up integrals according to what's described. All right, this one is a packet on volumes in general. A lot of these are old AP problems. If you can do them, you're in really good shape. It's 11 pages long.
Oh.
I don't think that's actually.
Extra credit if you do it.
You made sure that
I
you
would
would
do
never
that.
ask
I would do it.
for worksheets ever again.
Oh, this.
Because who cares about the trees?
I thought it was
Not this guy. All right.
Bro.
Finally,
Oh, they're multiple.
because Armand's not here, here are just general notes on the whole unit.
Why do I got to pick them up? It's for my sister.
Are there questions on the test multiple
Can you
choice?
not give me one? He's not gonna be here or Friday.
How am I petty? Because it's my sister-in-law. It's my sister-in-law.
Not as petty as me. All right, okay.
Think you're petty. So after this, we're done with chapter
7, yeah.
and then how many chapters?
2.
2.5.
Wow.
And then we're done.
Okay, so kind of.
Now we're really close to the end now. So we're done chapter 7 except for like
What's the next chapter?
chapter 8.
So like, what is it?
No.
about?
It's so chapter 8 in the textbook has some coherence to it. But we're just gonna bounce around and hit on like 2.5 sections.
What, like,
And so we're not gonna have any cohesiveness to chapter 8. So in chapter 8.1, that's just a review of all the integration methods we've seen so far. So 8.1 doesn't really need to exist, but it does just as like, hey, remember everything you've ever done with integration? Let's just do a quick review of that. 8.2 introduces one new method of integration called integration by parts.
Oh.
That's not on the AP exam, but because if you're going to get your 4 or 5 on the AP exam, and I expect several of you will, you should definitely take the credit they give you in college and not waste your time retaking the course. And some college courses in Calc 1 will cover integration by parts, and some college courses in Calc 1 don't. So whether you get integration by parts in Calc 1 depends on where you take your Calc 1. In case you go to a school that does integration by parts in Calc 1, it's friendly to you if you've seen it. I don't know, I jumped right into Calc 2.
Wow.
And then 8.7 is something called L'Hopital's rule, and that's for finding limits using derivatives to help us cheat.
I would not want to go back to the.
No, it's easy. So remember like back last year when we had limits and it was like, oh, you got 0 over 0. Now you got to like reduce this fraction. Now it's going to be easy. Now it's, oh, you got 0 over 0. Here's this trick. But I didn't show you last year. I didn't show you last year because last year when we were doing limits, we hadn't done derivatives yet.
Yeah.
Well, I couldn't because the definition of the derivative is based on a limit. So
I would much rather.
yes, again, because I'm petty. But also, this is a nice way that we like begin and end our study of calculus, bookending it with limits. So we started with limits, we end with limits, we came full circle. Hey, that's I think that in itself is a good reason to.
I feel like if you're gonna be getting good limits, it's a really lumpy circle, then you get to
The long version of limits.
Yeah.
Delta X again?
Yeah.
The worst things ever.
Yeah.
Oh, no.
I don't know why you haven't made a scoop. Because we haven't used them since.
They were so dumb.
What are we talking about? Wait, what are we talking about?
The Delta X.
Well, I was a jerk. All right.
That was.
So moving on. Example 3. We're gonna take this.
The delta x minus x.
Can you draw that?
Yeah, I don't know. Delta
Yeah.
x.
That's
What
fine.
about delta x?
For the AP exam, you need to recognize the formula for what it stands for, and if you see the limit definition of the derivative in that like limit form, you should recognize, oh, that's the limit form of a derivative. Identify what the function is and just differentiate that on your own. Don't drag yourself through the limit. So some limits you got to be able to do, but certain limits are like special formulas that are just, oh, this is just a derivative.
There's gonna be limits on the AP test.
Yeah, it's calculus.
That was forever ago.
That's why we're ending with limits. So the last thing we do before we get into review is limits with L'Hopital's rule. Yes, ma'am.
I'm sorry, I don't mean to be up time.
Go for it.
But that thing you had sent us for like practice AP test thing,
Yeah.
like, okay, so I did it, and none of this stuff was on it. It was just stuff we weren't even.
Yeah, I need to adjust that or add to it. I haven't touched Albert in months.
No,
So.
not Albert.
No, not Albert.
Outside thing, where you had to sign up and do it.
Oh, that thing.
But like none of this stuff was on it. It was just like, so is that like how the test is just like the calculation?
No, it's going to cover this stuff too. But we have to review all of it. We're going to have time to review because we only have a very little bit left to cover. Oh, a formula sheet?
Yeah.
No, I don't think so. Flashcards. So you have this enclosed space. When you want to find the volume that you get when you rotate it about some axis, you draw it, and then you got to make a decision. Are we doing dishwashers or are we doing shells? And then you got to set up the integral appropriate. This dxy thing is like, it's either dx or it's dy. Depends on the situation. And make sure you have your formula straight and be clear on what variable you're working within in a given situation. So let's draw it. We're starting at x equals 0. We're going out to x equals 1. X squared plus 1. Like that. So we have this curve, and that's the whole enclosed space. It's from 0 to 1 along the x-axis, and then from 0 up to the curve in the y direction. Any questions with drawing? Okay. Next, we have to decide, do we want to do discs or shells? So let's suppose we want to do discs, because that's the first thing that somebody said. And, oh, what are we revolving around? Y-axis. Always show the axis about which you're revolving. So if we're rotating around the y-axis, just do one of those things around the y-axis. I've been doing that all the time, but I haven't been making like a big deal about it, but I probably should have been. Like in general, like always. Like for the test. It's helpful for the grader to know what you're doing, and it's helpful for you to know, oh yeah. So it's helpful for everybody. So we're revolving around the y-axis. So if we're going to do discs, and I always draw this little rectangle, how is my rectangle going to be oriented? Perpendicular to the y-axis or parallel? Perpendicular. If we're doing shells, then it's parallel. So your rectangle that you draw, shells, it's parallel, shell, parallel. Disc, perpendicular, that doesn't rhyme, but shell, parallel, all right? So if the rectangle is parallel, you're doing a shell. There's your mnemonic device for the day. So we're doing discs, we said. So we said, all right, let's do discs. For discs, we've got big R. And what's big R? Nope, we're doing discs. So
Can you just take out the rectangle?
1 minus, what's big R? 1. And it's all the way up, right? So as you take this rectangle and imagine it like sliding all the way up the enclosed space, it's always R. Now, as you get up here, what's going to happen? It changes. So, does big R change? No. But now we have little r. Little r is, so r is the distance from who to where?
The axis to the R.
The axis to the John, to the curve. So from the curve to the axis, what's the equation for the curve in terms of
The curve
y?
to the axis is the curve minus 0.
So it's curve minus 0. And now we're doing things in terms of y, so we got to rewrite the curve equation in terms of y. So it's going to be square root of y minus 1. Y minus 1. I said y minus 1 and wrote the opposite. So square root of y minus 1 is your r. What? Why are we in terms of y? Because we're disks revolving around the y-axis. If you're, yeah.
So from the x-axis,
Edgar, sorry to track, but for little r, you said 1 minus 1?
Yeah,
Or,
r is the square root of y minus 1.
no, big R I meant, sorry.
Oh, big R is just 1. Because big R is the distance from the axis of rotation to the right outside edge of the disk. And the right edge of the disk is always 1. And we do have to make two integrals. So there's going to be two regions. Michaela and then Noel. Oh, it is washers on the top half. Disks and washers are the same method. Washers are just disks with a hole punched through it. Noel?
Why can't we? Alright, okay, alright. So we got shape, right?
Yeah.
Right? Very, very that.
Yeah.
Why can't we do this in say shells?
We could, but somebody decided we should do this.
But then if we do shells, then we're gonna do
So are you still looking at this and saying, could we just do shells, please?
No, I want to know what happened is.
It's much easier, right?
Yeah, shells will be a lot easier.
Well, let's go
So we're not doing this.
Let's set up the integral, and then we'll go back and do shells. So we're not going to solve it all the way out. We'll just set up the integral. So, integral from who to where? 0 to 1. And from 0 to 1 is just dy.
What is going on?
Now, why is that? Because that's this section. From 0 to 1, it's just boom, a disk of radius 1. And then we continue on and we go to, what is this? 2? 1 to 2. And for the second integral, 1 squared minus root y minus 1 squared dy.
So it's 1 minus 1 minus 1.
So 1 minus the quantity y minus 1. So negative y. Yeah. So this ends up being integral of 1 dy plus integral of 1 minus y minus 1 becomes negative y dy. So getting to here is a pain in the neck, as we just saw with this huge discussion. Those are very easy integrals to then evaluate.
Why is it negative 1? Why wouldn't it be minus 1?
Oh, you're right. 2 minus y. Yes. Michaela. Oh, geez. I forgot the pi. You're right. I was so focused on the integral, I forgot. Yeah.
So maybe we should put the test.
4-point Michaela as well.
Can we just
Well, with shells, we also have the 2 pi.
No,
So-
that's right.
No, you're fine. This is good. I was making those mistakes on purpose to make sure you guys are catching them along. So that's your setup. Once you get to this point, you're in good shape. Don't forget pi with your integrals when you're doing anything revolution based. Now, let's back up and say, well, what if we did shells instead? Because that was awful. So what if we go back and say, let's do shells. So draw it again. 1 to 2. Like that. No, that was disc washers. This is now going to be just shells. Shells doesn't mesh with anything else. This is just shells. So if we're doing this in terms of shells, which way is our rectangle going to be oriented? Parallel, yeah. So shells are parallel. So you look at your axis of rotation as the y-axis. So you draw your rectangle parallel to the y-axis. There's your rectangle. And then for shells, we need R and H. What's your radius R of the shell away from the axis of rotation? So it could go out as far as 1, but we have infinitely many shells here. Each shell is x spaces away from the axis of rotation because it's just existing at a location x along the x-axis. H is going to be what? Yeah, x is just the height of the curve. In terms of x, so that's x squared plus 1. How do we know we're in terms of x? Look at the radius. That helps things out. So shells, I don't know, am I in terms of x or terms of y? Look at your radius, that'll tell you. And then once you've got those, you say, all right, cool. Volume equals 2 pi, there, I don't forget that. Integral, we're working in terms of x, so along the x-axis we're going from 0 to 1. And then r times h is x times x squared plus 1 dx. So a lot easier to set that up than it was with discs and washers. So good news, there's always shells. Bad news, shells doesn't always work. But just like with discs that we learned first, discs doesn't always work. That's why we have the shell method as well. So we need to be able to be somewhat fluent in both languages, shells and discs, and be able to do both of them as needed. And the big thing is going to be, how do I decide which is better? If you just jump into, let's do discs, and then you get partway through and say, this is awful, let's switch gears and go shells, you can do that. As we were starting to discover as we tried to do the discs. Because that disc was requiring first a disc and then a washer, 2 integrals that you had to switch over as you went along. That's a pain in the neck. Any follow-up questions with that? What? We're semi-reviewing and semi-finishing up 7.3. It kind of overlaps at this point.
Which one should we like default to? Or should we like always like if you like really don't know?
Like if you really,
Fair game, default shells, and then just like figure it.
I think, yeah, get something, whatever you're more comfortable with. If you're more comfortable with shells, then default to shells, and if it doesn't pan out, then switch. If you're more comfortable with discs and washers, default to discs and washers, and then revert to shells. That doesn't pan out. But
Without
I-
working, like when I just know myself.
I think that's a reasonable way to go about it. You got to be careful on like a multiple choice question. They might say not what's the volume. They might say which of these integrals could give you the volume, and then the integrals that they're giving you are kind of guiding you towards one or the other. And at that point, your hand is kind of forced in that direction by the multiple choice answers. So I don't know. Maybe they're like clearing out space for a fight. Who knows? Or maybe it's circle time over there.
So, like,
Oh,
if I
speaking of, your flex lesson for the week is in the folder for today. Color-coded passes for the hallway next week. Color-coded hall passes.
No,
I mean,
Now you know.
what? I mean, there's the.
Anyway,
the
so
yellow
back to
and the
this.
black.
It's not important. We're back to this.
Okay, so like, if I went to the test and I like probably remembered like shells, would I be okay?
I wouldn't say you'd be okay because there's going to be things that say use discs, or the multiple choice section guides you towards discs. Yeah, but and there's certain times shells doesn't work. Like we've also seen discs and washers don't always work,
Yeah.
like at all, which is like in the example that we did yesterday where we introduced shells. There are situations where shells isn't going to work,
Okay.
and you have to do discs. It's not like a preference, or it's not like a, oh, this is easier. It's a, this is the only way, because the other way just isn't going to happen.
So, would you say that there's certain diseases around that kind of
Yeah.
well, then some people overdose on
Yes.
right now.
We can start to.
When does class?
So if orienting your rectangle, it's all about how you orient the rectangle. If you orient the rectangle one way, and you can see that's not going to change who's top and who's bottom, then you have it oriented a good way. If you have it oriented a certain way and you see as we move this across the interval, the inside and outside part is going to change, we try to avoid that if possible. So that's one thing. Secondly, if like both edges of the interval are based on the same curve, like if your curve does one of these, and we're rotating about this axis, if you try to draw a horizontal rectangle, both sides of the rectangle are based on the same curve. That's yucky. That's a situation where we say, you know what, let's orient it this way. And then the top is based on the curve all the time, and the bottom is based on this horizontal line all the time. So we like the two edges of the curve to basically remain constant in terms of what they are. Is it always the curve and then always some other curve or some other horizontal line? Then great, orient it that way. If both edges are based on the same curve, we try to avoid that. And if the edges of the region kind of change what they are, so on this side it's always this vertical line, but on this side it's a vertical line and then something different, we don't like that. So those are things to try to keep in mind as you go through. And that's where your discs versus washers worksheet that I gave you can be helpful. Is one of those things I gave out. Your homework for tonight is another 1, 2, 3, 4, 5, 6, or 7 problems in the book. So continue doing those to practice. I can't remember what day I have that as being due, but whatever it says in Schoology, we'll go with that. And then tomorrow we have like 2 more examples that I want to look at in here together after going over the homework, and 1 more homework assignment. And then Friday is review. And I could go with Monday review as well, because I think it might be good for us to go back and talk about area as well and look at some, like the big area packet that I gave you last week and the big volume packet that I gave you today, the one that's like 11 pages. Those have old AP problems that I think it's worth us to like have a chance to you guys discuss with each other about. So your test will not be Monday. It'll be Tuesday, Wednesday. It will be a 2-day event. I'm looking at it. I don't see how I can pare it down to 1 35-minute period and also cover everything I wanted to cover. So it's going to have to be 2 days. So it's going to be Tuesday, Wednesday.
How do we make it not out of pocket or
Do it really well, and then it will not out of pocket your grades. I didn't know out of pocket could be a verb. We'll see. And depending on, because the second half is on Wednesday, I don't necessarily have everybody here on Wednesday. Like I don't have today Armand, Marie, Zane, Stanley, Charles. So yeah, it'll be today. Right? So I can't guarantee I'm going to have it graded in time to go into the grade book. So it probably ends up being like to the.
Oh, so if everyone staggers their absences.
Which is what happens naturally anyway.
Okay.
Alright, half
So-
of us can't be
So
here.
make it like the first graded next March.
What if I just tell you it'll be in the 4th quarter?
Yes.
Yes.
Okay.
Amazing.
We'll say it'll go into the 4th quarter,
That's awesome.
and that way I'm not trying to